This had to be a tourist experience like any other tourist experience, that you could turn up really quite close to the flight, with in average health and fitness, without any special experience, and pretty much sort of climb on, take the trip, and then go off back to work again. And one of the really interesting things that we've done in the last couple of years is to build some data about the effect of G forces on the body. Now, the only data that really existed in the world before we put some new data together was that collected from the people that tend to pull high Gs, and those people, are fighter jet pilots, they're professional astronauts, and others that tend to be pretty young, mostly male, and at the peak of physical fitness. Our customer base, with all due respect to the two that are here today, are pretty much like that, So, but no, the average age of our customers, the customers that have signed up is about 55. We have 300 of them now, by the way, from 40 countries around the world, and they have a very sort of normal range of health conditions, fitness conditions, and so we took the first 100, including Bill and PJ here, and we invited them on a brief trip to Philadelphia, and then we put them through a pretty intense experience in a centrifuge, having done some medical work beforehand. And so the centrifuge in Philadelphia is actually able to replicate exactly the flight profile that will be experienced in Spaceship Two. So you pull about 3.5 Gs on the way up. You actually peak at 6 Gs on the way down. And the experience there has been that there have only been 2 people in that first 100 who we were unable to put on the centrifuge. Okay. And so we are very, very optimistic that most people, providing you're in reasonable shape, there will be no problem in taking this trip at all. The human body is very robust. Okay. The oldest person who's done this centrifuge training is an 88-year-old man from the UK. And he smiled.
Sounds promising. Okay, I'd love to open up questions for the audience. I'm sure there's going to be loads. If you don't mind hanging on for the microphone to be placed into your hand before asking the question so that everybody can hear, that'd be great. This gentleman, please.
My question. So, what do you think of the Orion Project? NASA's return to ballistic rockets and the RAs and Orion Project a step back?
Sorry, just the first.
The NASA Orion RA's project. What do you think of it? Is it just a step back to ballistic rockets and a step back in time?
Well, it sort of would appear to be, wouldn't it? The United States are in a very strange position at the moment as far as manned space travel is concerned. The shuttle, I think, was probably, with hindsight, a misconceived design. They tried to combine payload with people, which ended up in a very big and a very complex vehicle. And the space shuttle is retiring, or due to retire, in 2010. The new vehicle that you refer to is not due to come on stream, I think, to 2016, maybe. And so there's going to be a gap in the which is never. It's almost unimaginable, really, from the United States, where they'll have no way of getting people into space. So they'll be using the Russians for that period. And then the vehicle that's planned, I think, is better in one sense, in that it's separating payload from people. But as you say, it's using a very traditional design. So it may be is sad that they're not sort of being a little bit more adventurous or a bit more innovative in the way that they do this job. But I think in the meantime, the private sector is going to have a lot of influence on the way that government astronauts get to space. I mean, I fully expect NASA to be a very early client of Virgin Galactic. It may be for scientific research to begin with, but it also may be for astronaut training at some stage.
Okay, thank you. Gentleman over here.
Richard, thank you for a brilliant presentation. Really fascinating. Really interesting. A question I have, I've always wondered, is how long would the client be up there for in suborbital? I've heard 6 minutes, and would that be enough?
Well, it's actually more like 5 minutes than 6 minutes, and it depends what you mean by enough. It would clearly be great to offer, hours or days, and we will be able to do that providing we get this first stage right. You're landed with science, unfortunately. In a suborbital flight, the way you get more weightlessness at the top of the parabola, because you're basically going up over the top and back down again. The way that you get more weightlessness time is to go higher. And in order to go higher, you've got to go faster. And if you go faster, you're going to pull more Gs. And if you pull more Gs, you're going to limit the number of people that are going to be able to take the flight. So you have to find a happy medium. If you sit here and look at your watch for 5 minutes in silence, it's quite a long time. I mean, it is, in our view, and certainly in Brian Binney's view, the test pilot, Mike Melville, the test pilot, it is a wonderful experience. I think people will come back absolutely overawed by it and probably wanting to go for longer next time. I've never had any doubt, having spent quite a long time with those test pilots, that this is not going to disappoint. I think the intensity of the experience from start to finish is going to exceed expectations.
What about the cost, Stephen? What can you envisage in 10, 20 years? Because £200,000?
It's $200,000.
Dollars, sorry, apologies.
Which used to be good, but...
for sort of the man on the street who's thinking, well, that's not going to be attainable for me. What's the potential for the price to go down? The
potential is great for the price to go down, and I think you have to look at the early days of aviation as a really good sort of example of how things can happen. I mean, Burt Rutan always talks about his grandfather, possibly his father, probably his grandfather, who was a very small child. Who was from a very ordinary family, not wealthy by any means, used to be taken to those early airfields to see the Ford Trimotors take off to do those very first small commercial trips across the US. And he used to look from the other side of the fence and see people in fur coats getting onto that plane. And he knew, at least in his own mind, he knew that he would never ever be able to do that. And of course, that patently obviously wasn't the case. But if it hadn't been for those first people who were able to be in the position of paying the price that it took to develop and to run those early aircraft, then we wouldn't have the industry we have today. So absolutely. I mean, I think history is on our side.
Definitely.
Again, it will depend on us just getting this first stage really right. And if we do that, then I think technology will move forward quickly. As soon as we've paid off our development costs, we'll be able to bring prices down, and we will do that. But how far and how fast, we will wait and see.
Absolutely. Okay, this gentleman.
I'm just wondering, you mentioned a few minutes ago there about the capability of the human body to handle G-forces, particularly in, let's say, short-term flights, like 2 hours or so. In future, let's say, when you begin to consider the actual possibility of long-term space tourism, and knowing that a lot of astronauts going up even for a week or so, first 3 days they get kind of a space sickness, and quite often come back with a kind of form of osteoporosis or loss of carbon to their skeleton. Are you going to be working on any sort of ways of compensating for that, particularly in longer journeys?
We're not working on that because we have to be very, very focused on what we're doing at the moment, which is the suborbital trips. The suborbital trips, you don't have any issues with that sort of thing because you're just not up there long enough. Which it may be a disadvantage from the experience, but it's certainly an advantage from a sort of a health and fitness point of view. The issues that we will have, I think, with health will be, some people get motion sickness, and we will need to deal with that and cope with it in a way, I think, which will not be too difficult because we have a period, 2 or 3 days, where we're going to be training people and preparing them for the trip. We're able to control diet. There are some very effective drugs on the market now. And also, if you're very careful about the way that you move around, particularly as you push away from your seat in zero gravity, that these things can be controlled so that you ought to have a virtually zero incidence of that sort of sickness. You're right. If you're going to be putting people in zero gravity, particularly people that are not super fit for any length of time, then it presents its challenges. But they're not necessarily challenges that we can't overcome. But it wouldn't be right for us to be focusing on those particular challenges right at the moment because we have other ones that we need to overcome first of all.
Okay, we have a question up at the back.
Yeah, hi, I've got a question. The way if a plane is flying over Irish airspace, we kind of own that airspace. And if you're, say, a Russian plane flying over Cuba a couple of decades ago, near America, you could be in trouble because that's American airspace. You're a UK company operating from New Mexico. Has there been any discussion about, I suppose, ownership of the space that you're going into?
Well, we're actually going to be a US company working from the US, but we're sort of British-owned group, which I think is quite nice. That the Brits will get there first. But the US, the US administration are absolutely behind this project. NASA are absolutely behind this project, and It's a very good question, but it's quite simple again for suborbital trips, because we're just going to be blasting up straight up into a very narrow little bit through a very narrow bit of airspace into the same bit of space every time and coming straight back down. So we're never going to be over anything other than a small patch of New Mexico to start with, unless things go badly wrong. And there's legislation which has been passed in the US 2-3 years ago, which was deliberately put into place to facilitate the start of commercial manned space travel. So it's given us a liability framework, and it's enabled us to go through a licensing process with the Federal Aviation Administration, and so they really sort of made clear, what we need to do in order to operate within the US as a commercial space line. This is also a system which can travel. I mean, that aircraft you saw, the White Knight 2, has a range of about 2,500 nautical miles. So the lovely thing about it is that we can actually take the system to anywhere in the world, and providing, again, as you say, you have the right regulatory environment, you have the right sort of surroundings on the ground, which typically are deserts or empty areas, that you have the right weather conditions, then this is something we can fly anywhere. And so, one of the things we plan to do in the future, as soon as we get the export licenses and the business is bedded down, is to be able to take the system to various parts of the world for maybe fairly short periods of time each year, and be able to run services from, whether it's the north of Sweden or somewhere in the Middle East or the Pacific. So you're able to attract a local population, but also for those that want to go again, you can get a different view. So if your first flight was in the US and you were looking down at the Pacific coast, I think it would be pretty attractive to go again from Kiruna in the north of Sweden and look at the North Pole, particularly if you can fly through the Aurora Borealis at the same time.
Which is a possibility, right?
Which is a possibility,
You're discussing that very
yeah.
fact. Excellent. Another question over here?
How long before you take the first group of space tourists to the moon?
How long, Stephen? How long?
Quite a long. If you asked Richard Branson that question, he'd be hopelessly optimistic about it and say that well, maybe not hopelessly optimistic, but he would say he'd love to stand on the moon before he died, and maybe he will. Again, I don't know the answer to that question clearly, but what I do know, as I said right at the end of the presentation, at looking at other industries, is that you can have industries which just go into this terrible period of stagnation, for particular reasons, largely because they tend to be in government control. And when they come out of that environment, you can see incredibly rapid innovation. And so, sitting here today thinking about, you and I stepping on the moon, it sounds a little crazy to me. It probably sounds a little crazy to you. But if we can get ordinary people up into space on a very regular basis and prove that it can be done, and we can make money from it as a commercial entity, then the technology is sort of there. I mean, we did it in 1969, and so it ought to be more than possible to do it again.
Thank you. We have a question.
How about the...
Oh, right, there you are. Go ahead.
So, after this, would there be a project for a space elevator?
A space elevator.
A space elevator.
I love it.
Just heard of it.
Yeah, no, it's... there are probably people in this room that could answer that question better than I can. I think the space elevator idea is, and somebody correct me if I'm wrong, but I think from a conceptual perspective is something which works. You're effectively putting an enormous mast attached to the Earth. As the Earth spins, it basically sort of flings the thing out into space, and you could actually transfer people or payload or both, sort of straight up the mast. The problem is what you make the mast out of, it's a carbon fibre derivative that they're looking at the moment. And somebody else interrupt me if you know more about it than I do. But
anyone?
PJ.
Yeah, there's been actually quite a bit of work on that over the last.
Sorry, PJ, bear with us. If you can grab the mic, thanks.
There's been quite a bit of work on that, and what reignited interest, and it's actually an idea that goes back to the beginning of the 19th century, it got the fundamental problem with it is to build anything that tall requires material with the strength way in excess of anything we've had. However, interestingly enough, carbon nanotubes on an individual basis are now have the tensile strength to actually do something like that. And there was actually an interesting lecture a few years back where the problem they're having is when you take those microscopic pieces of carbon fibre, and you basically spin them up into something like a steel cable. They're struggling to make that work. So I would say never say never. Remember, though, you would need to build it not just to 100 kilometres. Your drop-off point out there would have to be in geostationary orbit. It's 36,000 kilometres out, and you would need a counterweight on the other side of that, probably as far away again. So it is a monstrous engineering task, but it's a fantastic idea.
Thank you.
Thanks very much, PJ. Is that why you're sticking with Virgin Galactic for the moment, PJ?
Yeah, I'd go on that one too.
Yeah, I'm sure you would. Okay, we have a question up here. Thank you.
Yeah, hi Stephen. Just
Hello.
a quick question. How long do you think it before space hotels come into wide-scale commercial use?
Yeah, I think that could be quite quick, actually. You know, I mean, there is at least one very real space hotel project which is being funded by another billionaire, which has a prototype flying in space at the moment, actually using inflatable structures. You know, it's a real leap of faith as far as he's concerned, because he's building the hotels before there's any transport to get there. But that's the way it should be. And so again, I come back to my same old point. You know, if we can get suborbital right first, then I think orbital could follow quite quickly. It comes with some challenges, as the gentleman down here explained. But I think the structures will be up there, or at least available to be put up there in the very near future.
Okay, any other questions?
Oh, yeah,
yes, this gentleman.
Just 3 quick questions. Do you expect that you'll be operating a fleet of aircraft, or just an individual, or space planes, I should say, or just one pair? Secondly, what's the turnaround time of a single place plane going to be? And the last one, do you envisage any problems with passengers getting back in their seats, seeing as you allow them out?
Yeah. Let me do that last one first, because
It's more fun.
It's more fun. You know, it's a really good question, and one of the things that I always look at when I fly a lot now, and I generally try and fly on Virgin Atlantic, and if I'm lucky, I get an upgrade to the front cabin. And you know, if you ask any of the cabin crew on that airline, you know, who are the worst people at getting back in their seats? You know, when the seatbelt light comes on, they'll always say it's the upper class passengers, and because they sort of feel they've paid a lot for this flight, and nobody's going to tell them when they're going to sit down. You know, and there's almost a sort of a race to see who can be the last standing before you land. And so, you know, we do have to think about that. The great advantage in the spaceship is that, you know, that they will be forced to get back down on the floor, because, you know, when you go from 0 gravity to 1G, you know, there's only one way that you go, and when that's followed by 6G, you're very definitely on the floor. What we have to do actually on the way down, the spacecraft comes down belly first, and because you do peak at 6G with the deceleration, the most comfortable way to go through that is actually by having the G's coming from front to back. So we're going to get people lying down. They'll be prone for that part of the journey. And our current thinking is, rather than having seats that recline, so each passenger has, in that 23 seconds between 0 and 1G, has to find their own seat, so to sit down in it, lie down in it. It's much better actually to have the seats folded away completely and get them just to lie on the floor, because, you know, you're going to be there anyway. And as Burt, you know, if you have a reclining seat, it's one more thing to go wrong. Because if it doesn't recline and you're sitting up taking 6Gs, it's going to hurt a little bit. So, you know, Burt always says the most reliable bit of equipment in any aircraft or spacecraft is the bit you don't put in. So, you know, I think the floor is a good option.
Less is more. Then there was a question about, are you going to have a fleet?
Yeah, we're ordering 5 spaceships and 3 aircraft to start with. I mean, you know, providing things go well. I mean, we'll start the operation with 1 of each. The turnaround time is the aircraft can fly 4 times a day, and the spacecraft twice. But we won't start with anything like that frequency. You know, we're going to be doing 1 flight a week to start with, because the operation needs to bed down. And we know from running airlines that you need to build up that ingrained culture of safety in the people that are doing the turnaround and managing the ground facilities. And the best way to get it right is just to take it slowly.
And I'm sorry, your second question, was that covered? Okay, yeah, lovely, thank you. Okay, we have a gentleman up there as well. Go ahead.
Hi, thank you. Each project of this magnitude has its own problems, and you obviously overcome them within a decade. I was just wondering, in the detail, what was the biggest challenge that you had to overcome, whether it be in the material or the engine? What was the biggest challenge?
Yeah, I mean, the biggest challenge for Virgin, I suppose, propose, actually, I mean, if we leave aside Scaled Composites and Burt Rutan, who are actually building this, I mean, they obviously had their own technical challenges, but if we just look at this from a business point of view, you know, this is not a typical, or really the way that we would have chosen to do this, because we have a lot of experience as an operator, and we have a lot of, so we can be the Virgin Atlantic of space quite easily. We've got a lot of experience there. But this project, we're having to be the operator, but we're also having to be the Boeing or the Airbus, and we're also having to be the guys that are actually building the prototype of the commercial vehicles and testing it. So we're paying for everything. And it is being solely funded by Virgin. So, I think this is a more risky project, or at least we're in it in a way which we had no alternative, because you wouldn't really have been able, certainly in the early days, to attract external investment, which we would do in most businesses. So we had to take on the whole thing. So that really increases the risk for us, and it's a significant funding requirement. And so coming into what appears to be the mother of all recessions, that is potentially an issue. But we're very determined to do this, and we're a long way down the road. And actually, we are at a stage now, because we've got the vehicles built and they're very shortly going to start test flying, where if we wanted to attract some external investment, I think we probably could, and we may well do that actually, just to lessen that risk. As far as technically, which is probably where your question was, Spaceship One was a project which was really fairly straightforward, I suppose, with hindsight for Burt and his team. I mean, they didn't need to radically change anything in the initial design. Clearly, as they went through the process of flight testing, they made small alterations, and they learnt a lot from that prototype, which is now being built into the commercial application. I'm just trying to think if there's anything that comes sort of more to mind. But I suppose the big difference between the Spaceship One project and the Spaceship Two project was that Spaceship One was designed as a prototype. It was designed to win the X Prize, which only meant it needed to go to space twice. In fact, it went 3 times in 2004. Spaceship Two, the big issue is that we've got to get it to a standard of safety, which means that it can fly for maybe 5 or 10 years with tens of thousands of passengers. And so it needs to be built and tested to a completely different standard. And that's quite a challenge.
Okay, and we have one last question with this gentleman in the front.
Okay, to summarize, we all know about the Russians trying to capitalize on their space race achievements. So they're trying to have commercial flights as well, but it's all run by the national agency. But do you know about any other privately owned companies in the world trying to do the same, like trying to compete with you at this stage?
I know of some, but I wouldn't say that we would regard them really as meaningful competition. And most of them, well, I think all of them really are what I would call paper designs. They're still at the concept stage. Nobody has flown anything else, even as a prototype. I would say that any competition that is out there is at least 5 years behind at the moment, unless somebody's doing something very secret somewhere that we don't know about. And the big problem is funding, actually, because I think that Spaceship One and the design for Spaceship Two does the suborbital job so well, and we have made such a positive and meaningful, sort of progress in this project that anybody looking at investing money in the sector, I think we'd have to be pretty brave to back alternative technology, which certainly the things that I've seen doesn't do the job half as well. I mean, most people are still thinking about ground-based rocket technology, and as we discussed at some length, it has big disadvantages over air launch.
Okay, well, I'm afraid we are out of time now. Sorry, but that was thoroughly enjoyable. Thank you so much, Stephen Attenborough, everybody.
Thank you.